Hi, I'm Emily Abbott from the American Chemical Society. Welcome to this media briefing from ACS Spring 2022. Today, we're talking about sea sponges. They may appear inert, but these simple animals, yes, animals, are rich with chemistry. Scientists have uncovered many biologically active compounds from sponges over the years, and some have even become medications, which treat various viruses and forms of cancer. These life-saving small molecules originated from bacteria living within sponges, but now new research has uncovered an exception. This San Diego-based research team reports that sponges themselves, not their resident microbes, produce at least one promising group of disease-fighting compounds. We're joined today by Dr. Vikram Shende and Kayla Wilson from the Scripps Institution of Oceanography in San Diego. Thanks for joining us.
Thanks so much for having us.
Yeah, thanks for having us.
So Kayla, why do people study sponges?
That's a great question. So personally, I think sponges are some of the coolest animals on Earth. And so much so that I actually have a sea sponge here with me today. And this is normally displayed in my living room, which tells you how much I really like sea sponges. But this right here is a glass sponge. And if you can see, everything, this little cage here is actually made out of glass. And a lot of people, when they think of sponges, they think of something as soft and squishy, but most sponges actually have skeletons made out of glass, which is pretty wild. But people study sponges for all sorts of different reasons. So one reason is that sponges are very ancient animals. So there's some debate on how old sponges exactly are, but some fossil evidence indicates that sponges have been around for 1.8 billion years. And to put that into some context, most animal life evolved on Earth around 500 million years ago. So potentially sponges have been around for a very, very long time. Another reason that people study sea sponges is that they have this complex microbiome, just like we have a complex microbiome. So a microbiome is a community of microbes like bacteria and viruses that live within and on our body. So we have a gut microbiome, a skin microbiome, a mouth microbiome, and all of those microbiomes really contribute to our health as humans. And the microbiome in the sponge also contributes to its health. And finally, the reason that I study sea sponges and the reason that my field studies sea sponges is that they contain life-saving medicines. So most people don't realize this, but the first FDA-approved antiviral drug, acyclovir, was derived from a sea sponge back in the 1950s. And acyclovir has gone on to inspire other antiviral medications like those that we're using now to treat COVID-19.
Very cool. Before I read your study, I had no idea that sponges were actually classified as an animal. So how do you get samples from a sponge? I mean, can you just like cut a piece off?
Yeah, so I think, it's pretty common that people don't realize they're animals. And honestly, it's probably pretty common that people don't think much about sea sponges at all. But, sponges don't have some of those features that we think about as associated with animals. Like they can't really move around that much. They can't like walk across the ocean floor. They don't have internal organs, and they don't even have a nervous system. So they can't feel pain as far as we know. So for my work, I do actually just cut a little small piece of sponge off of the sponge, but because they don't feel pain, I don't feel that bad about it. Also, they are really good at regenerating their bodies. So they've done some really cool studies where they essentially took a sponge, put it into a blender, blended it all up and created sort of like a sponge smoothie. And then if they pour that sponge smoothie into a petri dish, over the course of a couple weeks, the sponge cells will actually reform into a new sponge body. So sponges, they're pretty hardy. Cutting off a small piece of them probably isn't going to hurt them. And plus, we only need a really, really small piece of sponge to be able to study them. So we're not taking that much.
Boy, a sponge smoothie.
Yeah, yummy, right?
I don't know. So how did you get the idea for your project, and what do you study? What have you discovered?
Totally. So personally, I really love the ocean. Like I'm an avid scuba diver and sailor. And back when I started my PhD, I just wanted to find a project that would let me get into the waters here off the coast of San Diego as much as possible. So as I started to look into research that had been done here in San Diego, I discovered the work of this professor named John Faulkner, who used to work at Scripps and study local sea sponges here in the 1980s. And what I found was that he was working on this local sea sponge that makes these compounds known as terpenes. So terpenes are probably best known as plant molecules. So there's terpenes in lemons that make them smell like lemons, and that terpene is called limonene. And there's a terpene in pine trees called pinene that makes them smell like pine trees. And also terpenes have been turned into life-saving drugs like the anti-malarial drug artemisinin. So terpenes are really cool, and they're also found within this local sea sponge. So the goal of my project was to go out into the local environment, find that same sea sponge that was making terpenes that Faulkner was working on back in the 1980s, and then figure out how those molecules were actually made. Because John Faulkner, he did do some work trying to figure out how those terpenes are made in the sponge, but he couldn't figure it out. And even back in the 1980s, he was quoted as saying that figuring out how these terpenes are made in that sponge is the most interesting study in our entire field. So I was really excited about going out and finding the sponge and figuring out how it's made. So I went out, I collected a sea sponge, that same sea sponge that Faulkner is working on, that actually looks a lot like orange chicken that you might get at a Chinese restaurant. And I took that orange chicken sponge and I sequenced its DNA, of the DNA of the sponge and its microbiome, I should clarify, to figure out if I could find the genes responsible for making terpenes. Now, lots of other researchers have had success using similar methodology of going out, finding a sponge, sequencing its DNA and the DNA of its microbiome. But every other group that's tried to look for genes responsible for molecules in sea sponges have found that the microbiome is the one that's actually making the molecules. So that's led to a paradigm in our field that if you find a molecule in a sea sponge, the real producer is the microbiome and not the sponge animal itself. However, when I went into the DNA of the local orange chicken sponge, I found that the genes responsible for making those terpene molecules were squarely in the sponge animal DNA itself. So this is the first time that we have found molecules responsible for a sponge molecule in the sponge animal itself, which really shifts the paradigm in our field about who's making sponge molecules.
Very neat.
Yeah.
All right. So Vic, same question to you. What inspired you to study sponges, and what have you found?
Yeah, it's a really great question. So I'm from the Midwest, so I don't get to spend a ton of time around the ocean when I was growing up. So just getting a chance to come here and explore a new environment and brand new organisms was already really, really exciting. But what was maybe the big impetus for me coming here was, like Kayla mentioned, sponges are incredibly important sources for pharmaceutical leads. But one of the things that really inspired me to come to Scripps and join the Moore Lab was some work that they did before I had a chance to get here. So people were doing this like really, really cool work that what was going on was they were finding these halogenated molecules, so bromine and chlorine containing organic compounds, which looked just like flame retardants, but these were way out in the ocean, pretty far away from people. So it wasn't clear if human pollutants were making it all the way out into the ocean that far, or if something else was going on. And so what Brad and his students discovered was that the bacteria inside the sponge were actually responsible for making these compounds, and that these brominated compounds were affecting the way that the nearby coral larvae settled. And I just thought this was the coolest thing in the world. And it really got me excited to see, what local Californian sponges and their microbiomes could do. So I had a chance to work with some really talented undergraduates, shout out to Sam and Vivian. And we took about 13 different sponges and profiled what all kinds of chemistry that they were making. And we found another really interesting halogenated molecule that's shown some really, really promising antibiotic activity. And so we're really excited to see what else is going on there.
Great. So what applications does this have? I mean, can you just take a compound out of a sponge and pop it in a pill?
Yeah, that's a great question. So, of course, we're really interested in the potential of these compounds as antibiotics and for human health. But along with the molecule themselves, we're really fascinated with the chemistry involved in the assembly of these compounds. And so biocatalysis, or enzymes that perform challenging synthetic reactions, like, in my case, selectively putting a halogen onto an organic molecule, is a really nice complementary and environmentally sustainable approach to traditional organic reactions. And we see more enzymatic reactions in process chemistry routes to pharmaceuticals every day. So along with, trying to find molecules and get them into the clinic, we're really excited to find the types of enzymes that are making these molecules in our sponge metagenomes.
So what's the one thing that you want people to take away from your research?
Yeah, so, I think that there's lots of reasons to appreciate your local biodiversity. Aside from conservation, what's really cool about the work that Kayla's done and the work that I'm doing with my students is that we can find molecules that have real potential to make major impact in our own backyard. It just so happens that our backyard is the Pacific Ocean, And so I really want people to take away that, it's important to preserve local biodiversity, not only because of environmental reasons, but because we have this incredible treasure trove of molecules that might end up making life-saving medicines. And, if you're coming to San Diego for the ACS conference, I would really encourage you to come to the beach, go to the tide pools, go to the Birch Aquarium just up the hill from us, and have a look at some of the incredible local flora and fauna that we have here in San Diego, and think about the impact it could have on you.
Thank you so much, Vic. And thank you so much, Kayla. It's been really great learning a little bit about your sponge research today. Those are all the questions I have for you. And we really appreciate chatting.
Thank you so much.
Thank you so much. Thanks.
Be sure to check out our other media briefings for ACS Spring 2022, which will be posted throughout the meeting at www.acs.org/ACS Spring 2022 briefings.